everybody. This is Veronica Chevelle in the Reno office. And what we are going to be talking about today during this Lunch and Learn is one of the products put out by Simpson Strong-Tie, their hurricane clips. And I have focused this discussion more narrowly on the H1 clip for the most part. As many of you know, the H1 clips are typically used when we're trying to fasten and create a positive connection between a wood rafter or a wood truss to the double top plates. Now, oddly enough in this photo, they don't note that this connector is actually good for uplift, direct pull up off the top plates for this member. I have heard from some of the offices that they don't generally run into net wind uplift, where you take the wind pulling up on the roof and subtract the dead load that's prescribed by the code, and then actually have a situation where you can have uplift. Despite the fact that it may not be common in some of the other areas in which we design, it certainly is a real thing that happens, especially if you live in hurricane country. We don't live in hurricane country, but it certainly is a very real phenomenon when you live somewhere that has an exposure C or D, or if you have a high wind load. So the nuts and bolts, here we go. I'm sure all of you recognize this from ASCE. This is our wind table. And very clearly, they think this is a real thing that can happen, which in our experience it is. So using that, of course, we go into whatever spreadsheet that you are using for your office to go ahead and find your net wind pressures up. In the Reno case, of course, in this area, we're 130 miles an hour, which might be a bit higher wind than you're used to seeing within exposure C. So if you have a light roof, like a composition tile or something like that, it's really not hard to get there pretty quick. So what I'd like to bring to your attention is that Simpson Strong-Tie, although they don't really come out and say it too clearly in their catalog, they have issued this technical bulletin in which they discuss, and rightly so recognize, that if one of their hurricane clips, this is not an H1, this is probably an H2 or 2.5, but if their clips are not installed on the proper side of the wall, meaning the side that has a positive load path down through the system, or the outside, you can have a situation that looks like this. If you get the net wind pulling up, this can actually pull and tear out of your gypsum wallboard. And you can get this kind of bending over or cranking of the double top plate or rollover. I would greatly encourage people to take a look at this bulletin. It's not something that most engineers that I've run into are aware of, mostly because I think what you're going to find out is these clips predominantly are installed on the inside of a wall where they do not have a complete load path down to foundation. This is actually the second page of that technical bulletin. They're pretty good about explaining how these the hurricane ties can be installed. Of course, they can be put beneath the wall sheathing. That's fine, because the wall sheathing is actually connected to the double top plate. And that's what they're trying to tell you right here. They also have the scenario where, hey, you can put that hurricane tie over the wall sheathing. Now this is important because you have to understand the sequencing of construction. How do framers like to put their walls up? Well, they like to make life easy on themselves. They generally build these on the ground. And the more they can do on the ground, the easier it makes life. So, all right, hey, they could build this wall on the ground. They can actually sheathe it on the ground. And they can put this clip on it on the ground. The problem is when they go to put their trusses on the roof, if this clip is sticking up and they lift these trusses up in a bundle and they start dragging them across a roof plane, they're going to bang into these clips. This is kind of an atypical picture. This doesn't really show any wall sheathing on here. Maybe this is someplace where they don't have wind or earthquakes, who knows. Maybe this framer just elected, hey, I'm going to come put the sheathing on after the walls are built. I don't know, but it does show how we've got a nice flat plane here and how they would just drop a bundle of roof trusses up here and then quite literally drag them across the roof to their positions and then nail them off with those clips. So it really doesn't answer the question, well, why does the clip get on the inside of the wall? Well, if you're up here 2 stories in the air, where's it easiest for a framer to nail a clip? From standing inside, right? He can reach it from the inside to put a clip. Pretty tough to get from the outside and nail the clip in the correct position. So 2 things are going on. A, they don't want those clips in the way when they go to roll the trusses out, so they don't put them on ahead of time. And then once they get up there in the air, it's easier for them to get in and nail that clip from the inside rather than the outside. This doesn't have to be a 2-story condition. I think you'll find out that they are so used to framing this way that they nearly always put these clips on the inside, which, as we saw back here, is not per the recommendations or guidelines of Simpson Strong-Tie. So I did a little digging. I found these guys happily at work. Look, they're putting up their trusses. Oddly enough, they have their clips in place as they're going, but they are not doing the typical dragging the trusses across the line. It looks like in this particular case, they're actually hoisting them up one by one into place. And unfortunately, I think you'll see what's going on. Here are our little clips, wrong side of the wall. So does this happen often? Is that a real thing? Am I just making that up? Well, I did a little digging, just didn't take me long. Went out in my garage, boom, and there it is on the inside. Has my house fallen down? Has the roof sucked off? No. I do have a concrete tile roof though. Here's a picture of a big, huge mansion, probably 5,000 square feet. They're building about 2 miles from my house. Whoops. Same thing. He'll probably have concrete tile. Maybe he doesn't have to worry about it. So the question is say you have a project and you have your hurricane clips, or the H1, that gets installed on the inside. What do you do? Because our typical detail does show it that way. Well, there are solutions that are at the disposal of the contractor. You know, he can go get these clips and go put them on after he's screwed things up, basically. Will they like you? Not so much. This is added expense, added work. If only they had done the clip on the outside. So let's take another look at something that's interesting about the hurricane clips and ties. As you know, they're going to give us loads for Doug fir and spruce pine. They're going to have spruce pine fir and hem fir as well. And if you take a look at these loads in here, they're quite a bit reduced when you look at the different species of wood for the net uplift. Well, why is that? What's so special about these guys? Well, you know what? You really don't have to care, right? Because look, we're saved. We are saved because we tell everyone in our general notes the specific gravity of the trusses that we use has to be 0.5, which is Douglas fir, right? So who cares about this? We don't need to worry about that. But say you did have to worry about it. If we go into the NDS, you can come in and find out what the specific gravity is of something that has shown up on your job, unfortunately. And sometimes, there it is hem fir. Even though you've told them not to do it, can it happen? You can find that specific gravity over here in this table. Come on down the line and find out that it's not 0.5. It's actually quite a bit lower. Hence, the reduction in the load. Right there. So, you know, we have these general notes that say Doug fir. Doesn't happen in the top chords. Well, here's a truss calc that I actually have in one of my files. And it looks like, they use the hem fir. Okay, well, you know what? Hey, maybe I don't have net uplift. Maybe I don't have to worry about this. Maybe the H1 clip will come save the day. Oh, look at this. We do have uplift. And not only that, It's in excess of just a basic H1 clip. So if the knee-jerk reaction is to stick an H1 clip on everything for a positive connection, is that the right thing to do? We have to take the time and look. We can't just assume. So looks like the best that we could have done with a Hem-Fur is about 400 pounds of net uplift. This guy had 631. You have to pay attention. You have to be on your toes. And then you get to call out the bigger guys. Again, does this work if this is installed on the inside? No, it sure doesn't. So the moral of the story is, don't take for granted our general notes and our typical details. We show what we would like them to do, but that's not always what's happening, and there's a reason for that. It has to do with the construction standards and how things are actually built in the real world. Remember, just because you call for it as an engineer, it doesn't mean that it's going to happen that way, because what's easier for them? Again, this is a strange bird. Maybe it's because these have a heel and they're able to lift over. I don't know. I don't know why they put these clips on the inside when they lifted the wall. Maybe somebody thought they were being smart and being helpful. But they did get it wrong, didn't they? So if anyone would like to look up this technical bulletin, you can go to Simpson Strong-Tie. They actually have a tab in their on their website, and it took a little digging for me. But I knew this bulletin was out there, and I've shown it to quite a few engineers. And if you get a contractor who gives you grief about trying to stick these clips specifically on the outside of the wall, you can pull this up and show it to them, because when they don't follow this, they voided the warranty on the product. They are no longer backed by Simpson, and they're no longer backed by us. So just something to look out for. Hope you all enjoyed this. Thanks.